Welcome back. We are in Chapter 7, Section 6. And a couple warm-ups just to recap earlier in this unit. When you're multiplying across like this, you need to look at the like letters. So we have 3y's, 2y's, and 4y's. So that is y to the 9th. We add exponents when we're multiplying. And then if you look at your x's, you have 2 x's here and you have 1 x there. So adding the 2 and the 1 is an x cubed. And then the numbers, you just do what the numbers are asking. Now, 8 times 3/8, the 8 actually cancels, so that's like a 3. And negative 3 times 3 is negative 9. So this whole first thing simplifies to that. It's a monomial that is a 12th degree. Which means it could have, if it was just x, it could have up to 12 x-intercepts. Okay, for me, when I have a negative exponent, the easiest thing is to flip it right away. So I'm going to rewrite 5x to the 5th, y cubed, z to the negative 8. I'm rewriting it exactly as it is. 4x squared, y to the negative 3, z to the 5. And then I'm going to square the whole thing. So I've flipped it and changed the negative into a positive. So now this squared goes through to every single piece. So 5 squared is 25. X to the 5th squared is x to the 10. A power to a power you multiply. Y cubed squared is y to the 6. Z to the negative 8 squared is z to the negative 16. And then on the bottom, 4 squared is 16. X squared squared is an x to the 4th. Y to the negative 3 squared is a y to the negative 6. And z to the 5th squared is a z to the 10. Next step. Negative exponents need to move to the opposite side of the fraction and they become positive. So now I have 25, I'll squeeze it right here, x to the 10, y to the 6, and then I'm moving this y to the negative 6 up, and it's another y to the 6. And on the bottom we have 16, x to the 4th, z to the 10, and I've moved that z to the 16 down, and it becomes a positive. Now we put our like terms together. So, an x to the 10 over an x to the 4, we actually bring that 4 up and subtract it. It's kind of like there's 10 x's on top and 4 on the bottom. So we're left with 6 x's on top. The y's we put together, that's a y to the 12. The z's we put together, that's a z to the 26. And then we have 25 over 16, which you can just leave. All right, next up we have diamond puzzles, and we're going to find the pattern and complete the missing values. So this should again be 2 numbers that multiply to give you the top and add to give you the bottom. So that one works out. 2 times 10 is 20, 2 plus 10 is 12. 3 times 4 is 12, 3 plus 4 is 7. 1 times 5 is 5, 1 plus 5 is 6. Okay, so 6 times 7 is 42, and 6 plus 7 is 13. So see if you can figure out this last one. 8 times what is 72, and that's 9. And then 9 plus 8 is 17. All right, we're going to add and subtract polynomials. And when you add and subtract these, you have to find like terms. So if we want to look for like terms here, we're going to look for all the x cubes. And we can put all these together. All the x cubes are like terms. Here's another one. And then all of the x squared y, those are like terms. So let's put those together. You should probably circle them on your paper. And then all of the x cubed y's are the same. Is that working better for you? All of the x's are the same. And then all of the numbers are the same. So I'll go ahead and move this because these are like a separate thing. They're not the same as the other blue color. Okay, so if you can only put like terms together, if we're going to add this, we're going to add 5x cubed and 8x cubed. That's 13x cubed. When you add x cubes, you end up with x cubes because you can only add an x cubed to an x cubed. Now we're going to add our x squareds. This is like a -1. So we have 37 minus 1. That's 36. Okay, I'm going to slash and dash so I don't lose that. We have a -2x and a +1x. That's a -x. You could put a plus a -1x. You could put a 1 in front of there. And then we have a -34 and a -12. Two negatives make an even bigger negative. You could make this plus a negative or a minus, and that is 46. So that's our answer. All right, I did that one horizontally. You can always rewrite this and do it vertically. So I can rewrite this 8x cubed minus x squared. Now look at that. There is no x squared term. So I could put like a 0x squared placeholder in. So I'm going to not look at this anymore because it's below. And I am adding. So I have my 2x to the 4th. It doesn't have any like terms to go with it. My -1x cubed and my 8x cubed is a 7x cubed. My 0x squared and my -1x squared is just a -1x squared. And then I have my 4x and my 34. You see how this is going in order of the x exponents? This is 5 terms, and it's a 4th degree. And then the last one is a subtraction. So we need to make sure we distribute that subtraction to every single term. This is really a -5x cubed, and then a +6x squared, and then a -4x, and then a +11. So if we want to rewrite this, so 4x cubed plus 7x squared minus 10x plus 5. And then if we want to bring this one down, -5x cubed plus 6x squared minus 4x plus 11. When we put our like terms together, we get a -1x cubed, a 13x squared, because I'm just adding the 6 and the 7. I'm going to make both of these plus a negative. So it's -14x and a +16. So this is our answer.